Welcome to Earth, a restless planet with a violent soul. When the molten rock that hides beneath the surface reveals itself, it explodes, slithers, jerks, sloshes, and sometimes kills. It is the driver of continental collisions and cracks. Volcanoes erupt, mountains thrust skyward, and cities wait to die. All because of the liquid rock we call lava and its parent, magma. It is a creator, shaping our planet into what it is today. But it can also be a destroyer, responsible for some of our most frightening nightmares. So strap in as we take an adrenaline-fueled ride through our lava-driven world. Welcome to heaven, with a window into hell. This is the big island of Hawaii, home to Kilauea, one of the most active volcanoes on Earth, and perhaps the best place to see a planet's labor pains as it gives birth to itself. For some, this dangerous stuff oozing and spitting out of the volcano is the lifeblood pumped from the heart of a hot and vital Earth. But a better comparison might be a bad case of indigestion. This is a planet that belches, vomits, shudders, heaves, and passes gas. Really nasty gas. Whether from a pulsing heart or a heaving gut, lava is our only concrete glimpse into Earth's interior, into an engine of creation and destruction that dwarfs all the powers of the planet's human inhabitants. Scientists study the sun, moon, and faraway stars. But in some ways, the center of Earth can seem more remote. So when clues to its inner workings appear on the surface, it's captivating. Follow this lava back down the tube into its home, and you're soon in the giant molten sphere that takes up the vast majority of Earth's volume, the mantle. Made of superheated rock so dense and hot that it moves like glowing taffy, the mantle churns in extreme slow motion. It's only about 2,000 miles down before you hit Earth's cores. But it may take millions of years for the molten round trip back up to the spewing spectacle that is Hawaii. To see just what lava can do, drain away the ocean and fly by the Hawaiian island chain, all children of volcanoes. Travel from east to west, and the islands grow progressively older. The youngest is Loihi. Although it occasionally spews lava, it might not break the surface for 200,000 years. Then there's Hawaii's Big Island with its 5 volcanoes, from seafloor to top, higher than the Himalayas. The further west you go, the smaller the islands get, sinking and eroding over time, each one a little older than the last. And all of them, like all land on Earth, born of lava. What's clear from the surface is that lava can create paradise. Within a year, on the scorched new Earth, vegetation takes hold. The volcanic surface is rich with nutrients, belched up from within. Eventually, sun, moisture, and microorganisms turn lava into soil, and life explodes. The gifts of the volcano have always lured humans onto its slopes. But what creates paradise can also bring disaster. In 2018, Kilauea began a months-long eruption, unleashing billions of gallons of lava that destroyed hundreds of homes and displaced thousands of people. Other eruptions have had a greater human toll. Mount St. Helens in America, Vesuvius and Etna in Italy, Unzen in Japan, Pinatubo in the Philippines. A litany of awe and terror. And the havoc hasn't just come from volcanic eruptions, but from those other terrible powers of the lava-driven world. Earthquakes, tsunamis, landslides, and a whole host of other deadly phenomena. Take a look at the places on the planet where volcanoes erupt and earthquakes shake. And suddenly, the world looks like something stitched together by Dr. Frankenstein. But these are not sutures. They're wounds in the world where the planet is ripping itself apart and bleeding out. And other places where it's smashing together and eating itself alive. It's at these seams that the vast majority of earthquakes rage and volcanoes explode. Why is Earth so restless? What causes the ground to shake violently? Volcanoes to erupt with deadly force? And mountain ranges to rise to incredible heights? The answer is plate tectonics. Lava is simply the visible part of what drives the action. The engine is the molten magma beneath the crust. Earth's surface is broken up into a dozen-plus chunks of different-sized plates, which skate around like planetary bumper cars. The plates float, despite their enormous mass, because there is denser material below. The continental parts of the plates are the lightest of all. They're granite-type stone, which may seem heavy to you and me, might as well be styrofoam compared to what lies beneath. A boiling pressure cooker of melted rock. Magma. Most of the boundaries between individual plates can't be seen because they're hidden beneath the oceans. Thanks to satellites and sonar, we know where and how impressive they are. Drain away the oceans, and we see a long mid-ocean ridge, where Earth is tearing itself apart and spitting up some of the highest mountains on the planet. Here, plates collide, move away, and slide past one another. And new crust is created as magma wells up to fill the void. Much of this underwater oozing takes the form of pillow lava. As the hot lava erupts on the cold ocean floor, a rounded bubble hardens quickly. As more lava pushes out from inside the flow, the pillow expands. New pillows burst through as the pressure increases. Equally spectacular are the smoking chimneys that are found along the ridge. Water that has seeped into the ocean floor is heated by hot magma and blown upwards. At the remarkable black smokers, water reaching temperatures in excess of 700 degrees Fahrenheit jets out. Their plumes can spread particles hundreds of miles away and release minerals that create chimneys up to 18 stories high. This geologic activity isn't confined to the ocean depths. There's one landscape where Earth is ripping itself apart, and you don't need a submersible to see it. This is Iceland, where a mid-ocean ridge managed to beach itself on land. Here, Earth stews in its own juices, much to the delight of humans, who welcome a dip into the geothermically heated spas that dot a forbidding landscape of black rock and blue-white ice. The cliffs here are the dividing line between the European and North American plates. And they're tearing away from each other at a rate of nearly an inch a year. This is one of the most geologically active places on Earth. Here, seemingly placid pools of water show signs of the violence that lies beneath the island. If you wait a moment, once the water starts to bulge, you better step back. And even under Iceland's glaciers, eruptions occur and wreak havoc. In 2010, ash clouds from Eyjafjallajökull volcano reached between 16 and 24,000 feet in the sky, disrupting flights for nearly a month and costing the European economy $5 billion. And it isn't the only sleeping giant lying in wait under the ice. The 6,500-foot-tall Bardabunga last erupted in 2014. And scientists predict that it won't be long before Iceland's largest volcano erupts again. Witnessing the chaos that occurs where Europe and North America meet, and looking east or west, you have to wonder, what's up at the plate's far edges? It stands to reason that if Earth's spreading here, it's got to be colliding somewhere else. And it is, sometimes fatally. Head about 5,500 miles east, and here's bustling Tokyo, smack above where the Eurasian plate hits the Pacific and Philippine sea plates. Let's try the other direction, about 4,000 miles west of Iceland. And here's the San Andreas Fault, where the North American plate hits the Pacific plate and runs just offshore of San Francisco. Tokyo, San Francisco. What do these two places have in common? In geological terms, they are cities waiting to die. So how did we get to this place where two of our most storied cities are on the endangered species list? To answer that, we have to go back to the beginning. Earth's dynamism was set into motion about 4.6 billion years ago, when on the edge of a spiral arm of one galaxy, a lot of space rubble starts circling in a slow gravitational dance. These rocks and gas are the remains of stars that exploded long ago. Eventually, this space junk begins to collect together under the force of gravity, lighting up from the energy of spectacular collisions. Planetoids smash into one another, causing some to shatter, others to merge. One planetoid will become Earth. It suffers constant cataclysmic bombardment and swells into a glowing molten ball. About 100 million years after Earth began to form, a change. Lava, the scum of the Earth at the time. This part of the molten magma sphere begins to cool and forms into a crust. For now, the crust will keep melting, but it's a start. Then something truly remarkable emerges. Lighter blobs of the molten Earth called cratons shoot to the surface and stick, giving rise to the beginnings of Earth's permanent crust. Meanwhile, the primordial Earth's interior has been belching out water vapor and other gases. Eventually, the atmosphere gets so saturated with water vapor that it begins to rain, in a continual downpour that drenches Earth for years. This leads Earth to take on its final form. A crust develops, thinner than a sheet of paper, with Earth the size of a basketball. And under that, a molten semi-solid mantle that boils in extreme slow motion. And finally, two cores, a liquid iron core, pulsing out a magnetic field that shields us from solar winds and cosmic radiation, and a solid nickel and iron inner core. By now, the remarkable process of plate tectonics has kicked into gear. Though how and when it started exactly, we don't know. Here's how it might have happened. At first, Earth had one giant supercontinent. Eventually, that landmass pulled apart and smashed back together, forming many supercontinents. After about 300 million years, the land masses separated and came back together once again in a new configuration, Pangaea. But then, Pangaea came apart. It's when Pangaea split that today's continents are thought to have formed. If you're confused, join the club. Even Earth seems confused. All of this movement made for a host of unlikely neighbors way back when. North America's eastern seaboard once rubbed shoulders with Chile. California and Australia were neighbors, if not connected. And Brazil was either connected to Nigeria or very close. So what forces are at work here? The rigid plates are driven by the slow movement of the super-hot semi-solid mantle that lies below them. Like hot soup boiling in slow motion, superheated magma rises to the surface, begins to cool, and then sinks back down to the bottom of the pot, where it is reheated and rises again. This cycle is repeated over and over to generate what scientists call mantle convection. But what's the heat source that keeps this engine running? Some comes from decaying radioactive material, but most of it is left over from the energetic collisions and gravitational crushing that created Earth to begin with. It's still trapped down there, and it wants out. So what does this mean at the surface? Two things. First, magma being burped up along the ridges is pushing the plates in their respective continents apart, resulting in the rifts we see in Iceland. Second, what goes on at the other end of those plates, the collision zone, may be equally important. Here, where the heavier plates dive under the lighter ones, yanked downwards by gravity, they haul along their plates back into the mantle. That's what we know, or what we think we know. The details of what's going on in the deepest parts of Earth that drive the engine of plate tectonics, we may never know. But what practically all scientists agree on today is that virtually everything on our planet is being shaped by plate tectonics, including the creation and destruction of life itself. There is one place on Earth where mountains stand as perhaps the greatest witness to the power of plate tectonics. These are the Himalayas, with Mount Everest their crowning glory. For those who attempt to climb it, it seems eternal, solid, and immobile. But looks can be deceiving. Everest and its Himalayan companions are slowly creeping upwards, even now. The Himalayas lay claim to 30 of the tallest mountains on Earth, and Everest, the highest of all, pokes a hole in the sky at 29,000 feet. On these mountains, higher than most humans would dare to go, you can find something fascinating: fossils from the depths of the sea. They are the remains of creatures from the trilobite family, some more than 500 million years old. How did they end up at the cruising altitude of an airliner? This dramatic episode of Earth's soap opera might be called When Continents Collide, and the result gives new meaning to the term upward mobility. It took place 175 million years ago, when something that looks suspiciously like India breaks off the southeastern tip of Africa and drifts north. Then, 50 million years ago, the leading edge of the Indian plate, which is oceanic crust, slams into the continental Eurasian plate. When the two continents meet head-on, the crust buckles upwards. The Eurasian plate crumples over the Indian plate. The collision of the two plates over millions of years has thrust the Himalayas and the Tibetan Plateau to their present dizzying heights. And they're still growing. Where they will stop, no one knows. GPS devices planted on the mountain show that Everest seems to be rising by an inch every 10 years. And that's how those little ocean-loving creatures got all the way up there. They used to live in the sea that India squeezed shut just before it rammed into Asia. But it's not just on land that these earthly collisions happen. Entirely different ones occur underwater. Sometimes, continental plates smash into ocean floor plates. Sometimes seafloor hits seafloor. And sometimes plates simply grind against each other, like ships passing too closely in the night. All to create topography as awesome as Mount Everest is tall. When the lighter continental plates crash into the heavier plates of the ocean floor plunges underneath, creating the very deepest parts of the oceans, its trenches. Let's drain the oceans once again and take a glimpse at the Pacific floor off South America. Here, the oceanic Nazca Plate periodically rams into and surges under the continental part of the South American Plate. In turn, the lighter South American Plate crumples upwards, creating the towering Andes, the backbone of the continent. This makes them unstable and dangerous. Here, strong earthquakes rumble and killer volcanoes spew. In some places, ocean plate converges on ocean plate, and the result is a catastrophic downward dance that creates devastating earthquakes. The Mariana Trench paralleling the Mariana Islands, for example, marks where the fast-moving Pacific Plate converges against the slower-moving Philippine Plate. One canyon, known as Challenger Deep, at the southern end of the Mariana Trench, plunges so deeply into Earth's crust that you could flip Mount Everest upside down and fit it easily inside. Here, too, volcanoes are born. Over millions of years, the erupted lava has formed volcanic rock on the ocean floor that piles up until a submarine volcano rises above sea level to form an island volcano. Such volcanoes are typically strung out in chains called island arcs. The intricate plate tectonics fringing the giant Pacific Plate that results in this bounding and plunging and scraping form what geologists call the Ring of Fire. This massive 25,000-mile ring quakes and explodes up through Java, the Philippines, Japan, and Russia, rumbles east along the Aleutian Island chain to Alaska, then turns violently southward down the western coast of North, Central, and South America. Destructive earthquakes, volcanoes, and tsunamis all find a home in this Ring of Fire. So that leaves a compelling question. Where can a human go to find a nice, calm, geologically settled place to hunker down? Clearly not where Earth is tearing itself apart and creating volcanoes and earthquakes. Or the places where Earth is smashing together, creating even worse volcanoes, earthquakes, tsunamis, and the like. Maybe we can retreat to the centers of the various plates and enjoy their quiet and tranquil beauty. The feel of solid, immobile rock beneath our feet, right? Wrong. Some of the scariest, most violent places on Earth lie smack in the middle of giant plates. There aren't many of these geologic hotspots around the world. But their impact could be more terrifying than anything humans have experienced before. So here we are, back in Hawaii, right in the middle of the giant Pacific Plate, thousands of miles from the Ring of Fire. At first glance, these isolated islands look like an ideal place to escape. But even here, danger exists. The physical evidence of the threat is lava, which tends to seep and spit lazily out of restrained volcanoes. It eats everything in its path, including what man has built, but usually moves no faster than walking speed. Only rarely have Hawaii's volcanoes lashed out explosively. What's Hawaii's secret? It's a plume of magma, a hotspot rising from deep within Earth's molten mantle that has somehow managed to break through the crust of the giant Pacific Plate. It has created in succession the islands of the Hawaiian chain until it reached here, under the Big Island and Loihi, the baby volcano that likely won't reach the surface for another 200,000 years. Because the Pacific Plate is moving northwest, but the hotspot itself stays put, each island is carried away as another one forms. The magma under Hawaii, rechristened lava once it emerges from its tube, is runny, almost liquid. It's been flowing out from under the Pacific Plate for millions of years. Layer upon layer of almost flat lava fields create rounded volcanoes that have been slowly building up from the sea floor. These volcanoes are called shield volcanoes for their gently curved shape. Despite their relative passivity, don't underestimate the tremendous power of these giants. Mauna Loa on the Big Island is more than 13,000 feet above sea level, which means it rises more than 29,000 feet above the ocean floor. This magnificent geologic feature would be taller than Everest if much of it weren't underwater. And what's above water makes up half of the Big Island. Although it's been quiet since 1984, it's an active volcano with 33 eruptions in the past 175 years. In contrast, its neighbor, Kilauea, has been disturbing the peace for more than 35 years. And in 2018, it became extremely violent. An explosion of activity was triggered when magma underneath Kilauea started to flow away from the deep crater chamber towards another part of the Big Island. This caused the walls of the summit crater to collapse. As the moving magma passed fissures in the ground, it erupted, spreading huge volumes of lava across the landscape. A lava channel seeping out of one of these cracks, Fissure 8, was so active it spawned a lava whirlwind. And it unleashed other threats. Once the 2100-degree lava hit the Pacific Ocean, it collided with seawater and created plumes of laze, a toxic mix of hydrochloric acid, steam, and tiny glass shards. Remarkably, in the first few months of this eruption, there were no human deaths. Why is that? Hawaii's volcanoes tend to have a slow and steady wins the race attitude that's reflected in their slow-moving lava, which comes in two forms, pahoehoe and a'a lava. Pahoehoe is a smooth or ropey lava flow, and it, along with a'a, splashes out of its volcanoes. A'a is a chunky, rough, broken lava flow. Over the years, the volcanoes of Hawaii have taken few lives. Only one in the last century. and possibly hundreds who happened to be in the wrong place at the wrong time back in the 1700s. Compare that toll to other volcanoes elsewhere. 36,000 killed by Krakatoa in Indonesia. The sound from its explosion was one of the loudest sounds humans ever heard. 30,000 killed by Palai in the Caribbean. Thousands more by Vesuvius and Etna in Italy. More recently, the death tolls have been lower, but the impact still significant. Nyiragongo, Republic of Congo, less than 100 dead, but 350,000 displaced as a river of lava covered 40% of the city of Goma. Mount Merapi, Indonesia. 379 deaths and 3.5 million affected when it spewed hot clouds of gas and ash over a densely populated area. Volcán de Fuego, Guatemala. Streams of lava and gas poured down its slopes, and ash spewed nearly 40 miles from the summit, killing more than 100 and affecting 1.7 million. Why is it that the volcanoes whose names reverberate through history lashed out instead of seethed? Why is this so terribly different from this, or this, or this? These look like real volcanoes, and they'll kill like real volcanoes. Welcome to the deadly splendor of the composite volcano, also known as a stratovolcano. Unlike Hawaii's shield volcanoes, which are flat and broad, composite volcanoes are tall, with steep sides, and they're violent. The steepness of their slopes hints strongly at their destructiveness. Famous composite volcanoes include Mount Fuji in Japan, Mount Cotopaxi in Ecuador, Mount Shasta and Lassen in California, Mount St. Helens and Mount Rainier in Washington, Mount Pinatubo in the Philippines. Some slumber, some smoke, and some wait. Why? Lava, apparently, has a very different personality from place to place. And in some locations, it's positively explosive. This is the lava from Mount Unzen in Japan. Notice how it doesn't run or flow or splash. It just hides under the rocks. And here's Montserrat. Its volcano just sits there. The lava's so thick it doesn't flow. Instead of sliding down the side of the volcano, it stays put. It grows spines, steams, and sometimes collapses. This lava doesn't melt. It's too sticky. It bulges out into a dome, the smoking silo of a natural bomb. When the lava-laden dome becomes too heavy, it can collapse, causing hot rocks, gases, and ash to explode out from the volcano. And what goes up must come down. The return of the flaming ash to Earth is called a pyroclastic flow, a burning avalanche that's hotter than your oven and moving at the speed of a bullet train. It's what stopped time for the Romans of Pompeii, entombed by burning ash in their attempts to escape. It's what swallowed a Japanese town after killing some of the most experienced volcanologists in the world. It's what left the capital of Montserrat in ruins. It's also what caused devastation around Indonesia's Mount Merapi and Guatemala's Volcán de Fuego. All around the world, stratovolcanoes like these are stockpiling their explosives, awaiting the moment when the magma below lights the lava fuse and detonates. Despite the destruction such volcanoes bring upon mankind, they are minor compared to the violence that the lava-driven world may have in store for us. On the day after Christmas in 2004, the world reeled at one of the worst natural disasters of our time, a huge tsunami. The cause of so much devastation? The most powerful kind of earthquake on the planet, a megathrust earthquake deep in the Indian Ocean. It killed almost 250,000 people. But if a megathrust occurs closer to the surface, the toll could be much greater. Megathrust earthquakes occur when one of Earth's plates subducts or plunges under the other. If the plunging plate gets stuck against the upper plate, the pressure builds until one plate suddenly and catastrophically releases, and a huge megathrust earthquake occurs. Widely thought to be the largest earthquakes the planet can generate, they often measure 9.0 or more on a Richter scale. And if one should occur on land, in a populated area, what then? Welcome back to Tokyo, home to more than 13 million people who live in a megathrust fault zone. About 140,000 died in the Great Tokyo Earthquake of 1923. In 2011, the world's fourth largest earthquake, measuring at a magnitude 9.0, struck off Japan's coast just 231 miles northeast of Tokyo. It triggered a tsunami with 130-foot-high waves and killed nearly 16,000 people. It also caused a meltdown at the Fukushima Daiichi nuclear power plant, displacing more than 100,000 people and releasing radioactive materials into the air and Pacific Ocean that drifted all the way to the United States. The fault could slip again. Magma is pushing the Philippine Sea Plate and the Pacific Plate under the Eurasian Plate, once thought to be 24 miles below the surface. We now know the fault between the plates is actually less than 3 miles down. That's why earthquake experts call Tokyo a city waiting to die. When the next big one hits, will Tokyo be leveled? Tokyo's geological nemesis could create a tsunami of immense proportions. But it turns out, it's not just earthquakes that can trigger a mega tsunami. Lying below the waves off the coast of Hawaii's Big Island, just out of sight, lie piles of rubble that extend miles out to sea. Apparently, that rubble didn't get there gradually. Instead, part of the giant Mauna Loa volcano may have collapsed catastrophically into the sea some 100,000 years ago, creating a mega tsunami that rebounded on the islands. Reaching a height of nearly 1/3 of a mile, the wave swept inland, tossing coral nearly 4,800 feet onto the great volcano's flanks. It would have dwarfed the tsunami of 2004. Off the sheer cliffs of Maui, even more rubble lies underneath the sea, evidence of an even bigger landslide. Apparently, these happen every 200,000 years or so. So, nothing to sweat about now. Perhaps. It's hard to imagine that Earth could have worse in store for us. But there's one place that may not lie quiet forever. Search the planet, and you'll find no landscape quite like this one. Here, more geysers erupt than anywhere else on Earth. This is the world's first national park, Yellowstone. America's most popular tourist attraction is also a time bomb of unimaginable proportions. Something so devastating, it could possibly change the global climate for decades. The earliest geologists to visit Yellowstone understood that all of this beauty had uneasy geological underpinnings. But many speculated that because no volcanic peak or crater was visible, Yellowstone wasn't a threat. Then, field research in the 1960s and 70s proved them wrong. Pull out to a satellite view, and something awesome and frightening becomes clear. Much of the park sits on top of a volcanic crater, or caldera, roughly 30 miles wide, a supervolcano. It turns out that Yellowstone, like Hawaii, is a hotspot, with a plume of magma welling up from the mantle. Also like Hawaii, Yellowstone is always active on some level. And that activity results in magnificent sound and light shows. But unlike Hawaii, when Yellowstone blows, it will really blow. The land here rises and falls, up to 10 inches, pushed upwards by a swelling magma reservoir. Scientists predict that one day this bulging molten lava will burst through Earth's crust. It's just a question of when. Although it's been 630,000 years since its last powerful eruption, Yellowstone is very much alive and kicking. When the Steamboat Geyser had a string of eruptions after a 4-year silence in 2018, some began to worry. But scientists confirmed Yellowstone wasn't about to blow. The last eruption of a supervolcano was in Toba, Sumatra, 74,000 years ago. It was 5,000 times greater than Mount St. Helens, and its impact may have been felt worldwide. So much ash was hurled into the atmosphere that it obscured the sun. The ensuing darkness could have caused temperatures to plunge for years in some places. Sulfuric acid shot into the atmosphere and became acid rain that fell from Greenland to Antarctica. Scientists aren't sure whether man settled in the region just before the eruption, but there's evidence humans as far away as Africa took refuge along the coasts to survive the environmental chaos. Although the chance of an eruption of that scale is small, if Yellowstone were to go off today, what would the impact be on humanity? No one really knows. This is a dangerous planet we've found ourselves on. Thanks to the magma machine that lies underneath us. But what may be disasters for us are entirely different things to Earth itself. The lava-driven world is similar to a living, breathing organism, full of stresses and strains, always seeking peace and equilibrium despite its internal conflicts. Volcanoes release internal heat. Earthquakes relieve stress on the surface. Life might have been born of lava, perhaps on some chemical wonderland created by smokers under a primordial sea. It almost certainly owes much of its diversity and hardiness to the plate tectonics that drives continents apart and smashes them back together again. Without lava, the world would be a cold, characterless stone in space. Instead, it blesses us with oceans and renews Earth's surface with rich, fertile land. It gives us a dynamic and animated planet, yet also holds our fate in its hands.